In the blink of an eye, a bullet tears through the air. Too fast for the human eye, too fast even for most cameras. But what if we could see it? Not just the blur, but every vibration, every ripple, every moment frozen in time. What if we could watch the impossible unfold at 1,000,000 frames per second? This is the story of the world's fastest camera and how it's rewriting what we know about motion, physics, and the very limits of technology. For decades, humanity has been obsessed with speed. From racing cars to fighter jets to the simple pull of a trigger, speed defines power. But no matter how advanced our machines became, one question lingered. Could we truly see what happens when a bullet leaves the barrel? The answer was always no, until now. At the heart of this revolution is a device that challenges time itself, the Ballistic High-Speed camera. While an average phone records 30 frames per second, and even Hollywood's best high-speed rigs reach around 10,000, these specialized scientific instruments can capture tens of millions of frames every second. To put that in perspective, a bullet traveling at 1 to 200 meters per second can be seen creeping forward, millimeter by millimeter. Every twist of its spin, every burst of gas, every shockwave becomes a cinematic ballet of destruction. The journey to this point began in the early days of photography, when pioneers like Edward Muybridge and Harold Egerton first tried to freeze motion. Muybridge's galloping horse proved motion could be split into moments. Egerton's iconic milk drop coronet revealed art hidden in physics. But their work was limited. Mechanical shutters could only move so fast. The next leap would take more than ingenuity. It would take light itself. Modern ballistic cameras no longer rely on moving parts. Instead, they use lasers, mirrors, and advanced sensors to bend time around light. Some models use a technique called streak imaging, which slices a single event into millions of temporal layers. Others employ ultra-fast electronic shutters that open and close in a fraction of a microsecond. Together, they create a window into a world that operates beyond human comprehension. Scientists began using these cameras to study the hidden dynamics of impact, how materials fracture, how shock waves propagate, how armor fails. In defense labs, they recorded bullets punching through steel plates, revealing new secrets about ballistics and protective design. In aerospace research, they observed fuel combustion, plasma bursts, and micro-explosions that occur in the blink of an eye. What once looked instantaneous now had a story, a sequence of events invisible to human eyes, but vital to scientific understanding. But beyond the labs, this technology carries something almost philosophical. Watching a bullet in slow motion is like seeing violence deconstructed into its purest elements. The explosion that propels it, the pressure wave that trails behind, the distortion of air as it cuts through, everything happens with mathematical precision. It's beautiful and terrifying at once. In those slowed-down milliseconds, we glimpse both the elegance of physics and the brutality of human invention. The world's fastest cameras also serve peace. Medical researchers use them to study blood flow and neural activity at microscopic speeds. Engineers use them to design safer vehicles, analyzing airbag deployment or crash impacts at the atomic level of time. Even artists have embraced them, turning bullets and bursts into surreal displays of energy and motion. In a way, these cameras transform destruction into discovery, pain into progress. The current frontier is astonishing. In 2020, scientists at Caltech unveiled a camera capable of capturing 10 trillion frames per second, so fast it can visualize light itself traveling through space. Imagine watching a beam of light, something once thought instantaneous, move like a wave, shimmering through air and glass. With each breakthrough, humanity inches closer to freezing not just motion, but reality itself. Yet the deeper question remains, why are we so fascinated by slowing things down? Perhaps it's because in a world where everything moves faster and faster, we crave the opposite. The slow reveals truth. The bullet that seems unstoppable becomes a study in fragility. The chaos becomes order. The moment of impact becomes a lesson in cause and effect. The world's fastest camera doesn't just record. It reminds us how much we miss when we move too fast. It reveals a hidden universe of patterns, symmetries, and consequences. Every captured frame is a story of energy and transformation, showing us that even the most violent acts obey the same timeless laws of motion and matter. As we look into the future, the frontier of imaging continues to expand toward quantum-scale motion, atomic vibrations, and even the speed of thought itself. We are entering an age where no movement is too fast to see, no mystery too brief to study. Humanity has finally learned to watch time unfold at its smallest scales. The world's fastest camera versus a bullet isn't a battle of speed. It is a confrontation between perception and reality, between what the eye can see and what truly happens. And as we slow time down, frame by frame, we uncover not just the science of motion, but the essence of existence itself. In the end, it's not the bullet that astonishes us. It's the moment we realize we can finally see the unseen.